Okay, now for this problem, okay, a bit of a challenge here to say the very least. We have our functions y is equal to the square root of x, y is equal to 0, and x is equal to 6. And we are looking at determining the volume about the vertical line x is equal to 9. Okay, and so if we look at the schematic here, okay, again we have y is equal to the square root of x, y is equal to 0, x is equal to 6. And we have for the line upon which the object is going to revolve, okay, we have away from the structure that is developed by these three given functions. Okay, 9 is away from all the activity that goes on inside the wedge itself. And we have for the key points here, we have 0, 0, 6, 0, and again we have the point of intersection at the top at 6 and the square root of 6. And we'll be looking at integrating over the line x is equal to 9, and for this revolution to occur and for the integration to also occur, we need to do this over the variable y. And the modification that needs to be made is with y is equal to the square root of x. And so if we rewrite in terms of its equivalent, here we have x is equal to y squared. And for what we have in this one, here we have y is equal to 0, x is equal to 6, x is equal to y squared. And we have, again, the boundary x is equal to 9. And for what we have in the setup, okay, we're going to have an open space, so we are going to be relegated to using the method of washers. And for the open space here that exists between the wedge and the boundary x equal to 9, you have a gap here. The open space is going to be the inside radius, and that is going to be equal to 3. And so far as what we have for the outside radius, okay, notice that at the base, okay, now the radius will be equal to 9, but as you go up the curve x equal to y squared, okay, the radius, the outer, is going to have a decrease in the amount. So while we have 9 at the bottom, okay, the radius is going to be at 3. Okay, once we proceed from, say, at the origin, okay, the radius is equal to 9, going from x equals 0 to x equals 9, and then for the outer we have, again, going to the point 6 and the square root of 6. And if you notice, okay, for the radius itself, once you get to this point, the radius is at 3, and everything else is going to have a radius somewhere between 3 and 9. Let's say that if y is equal to 2, your x value would be at 4, and the outer radius in this case would be 9 minus 4, which will be at 5. So the outer radius is not a constant, and in fact it's going to be changing at a rate of 9 minus y squared, and that is just for the outer radius. And again, the inside radius is going to be at 3. And in terms of the nature of the solid that is going to be constructed, okay, we have in this situation, okay, we have for the solid, okay, I know it's not drawn to scale or in proportion, but you have, okay, this represents x is equal to 9, x is equal to 6, and you have your x is equal to y squared. And for what we have, again, for the open space, okay, we have the inside portion of the washer, the hollow section, okay, you have the radius measure equal to 3. And again, for the outer layer, okay, we have, or the outside radius, okay, again, going back to what we had before, we had that the outside radius is going to be at 9 minus y squared. And in application of the method of washers, okay, again, you're looking at the volume, okay, going from y is equal to 0 to y is equal to the square root of 6. You have pi times the square of the outside radius minus pi to the square of the inside radius. And as we follow through applying the power rule and algebra, okay, we have, okay, the square of 9 minus y squared, we have 81 minus 18y squared plus y to the 4th. We have minus 9 pi dy, and combining like terms, say 81 pi minus 9 pi. Okay, this is going to lead up to, in this case, 72 pi minus 18 pi y squared plus pi times y to the 4th dy. And in the case of the step that follows, okay, you have the power rule of integration. And so we're going to have, in this one, we have 72 pi goes to 72 pi y. Negative 18 pi y squared goes to negative 6 pi y cubed. And as for pi y to the fourth, that is relegated to pi times y to the fifth over 5. As y goes from 0 to the square root of 6. And as you substitute and combine like terms. Okay, I already had this number stored in advance, so don't think that I was doing this in my head right away. And so for what the outcome will be is that for the volume of the solid generated about the line x is equal to 9, okay, this is going to end up at 216 times the square root of 6 fifths pi, and that will be the exact result for that problem.